Hi, I'm Brendon Slade from NXP Semiconductor. I'm here at ARM's headquarters in San Jose with Preetpal Kang from San Jose State University. Today we've been hearing some very interesting presentations about some self-driving vehicles his students have developed. And we're going to talk a little bit more about the details of those projects and what was involved. Preet, can you tell us a little bit more about the projects, what the objectives were and what your students were set out to do?
Sure. So we started this new class at San Jose State last semester, which is fall 2014, and we had a huge class of 75 students, so I thought about how to group them together and how to help them do something really cool that they can be proud of. So what we have here is purposely built 6 controllers communicating over the CAN bus to get them the exposure to the automotive industry, and they're all running free RTOS, so they also get exposure to the real-time operating system software. So we have 6 controllers communicating with each other, and some controllers, for example, are dedicated for sensors. Another controller may be dedicated for the LCD screen and output, and another controller can be dedicated for motor control, and there's another master controller commanding or bringing all the information together to drive the car. So what happens is one of the controllers communicates with an Android phone, and the Android phone using the Google Maps, you can tap into the Google Maps to set a destination. Once the destination is set, all these controllers communicate together over the CAN bus to autonomously drive the car to a destination. So that's the high level of all these controllers and what they do, and this is what came out of that class, which is one RC car, and we had 5, but we only have 2 for the demonstration today.
So I understand you developed your own board, designed it yourself over the last few years. Can you tell me why you chose the LPC1758 family for that board?
It just happens to be, by chance in the beginning, and later I really liked the data sheets that I saw from NXP. So I started with AVR processors about 5-6 years ago. Then I started using the LPC2200 series, which is the ARM7, and I wanted to upgrade that to gain more horsepower in terms of CPU and RAM, and then the next step was LPC1700 series. So these are Cortex-M processors, plenty of RAM and ROM and CPU space, and I think one of the things that drove me to the NXP from the ARM7 was just the backwards compatible peripherals and bootloaders and just good data sheets for students to have.
So I understand you're a big fan of the Cortex-M3 core. Can you tell me why that is, what you particularly like about it?
I think it's low power, and it can run an operating system, and also has the capability to integrate the MPU within RTOS. So also from a safety perspective, it's a good choice, and it's cheap. So it's something cheap that students can afford, and that factors into the overall cost of the board.
So Preet, I'd like to thank you for all the effort you put into helping educate our engineers of the future, and I think it's a very exciting project, and thanks for your time.
Thank you.